Hello viewers, myself Samarth Patel, and today I am going to describe the condition for neutral point, or we can say equilibrium position, for the system of 2-point charges. So let us understand by this condition. Here I am taking two charges Q1 and Q2 at some distance apart. Let's say these as R. So what is a neutral point or equilibrium position? It is the point in the line joining of two charges where another charged particle does not experience any force. Let's say here I am taking a point P where another charged particle Q0 is placed. So what will happen for this Q0? Due to this positive Q1, it will get repelled along this direction. Let's say this as F1. And again, due to this positive Q2, this Q0 will again repel along this direction. Let's say this as what? F2. Now the condition for this point P to be neutral point will be what? F1 is equal to what? F2. I mean to say, force due to the two charged particle will cancel out each other at this point P, so that this P will be in equilibrium position. Now, what is the value of F? The Coulomb force given by what? K Q1 Q2 divided by what? R square. So let's say this as R and distance between these as X. Then remaining distance will be what? R minus X. Now using this equation, what we can write? F1 will be equal to K Q1 Q0 divided by what? X square. And again F2 will be equal to what? K Q2 Q0 divided by distance between them. It is what? R minus X whole square. So using this condition, we can determine the position of neutral point. Let's say for this question, where two charged particles, one is 4 microcoulomb, other is 36 microcoulomb, both are separated by what? 60 centimeter. Now the question is that what will be the position of neutral point from a smaller charge? So let's say from smaller charge, the point P is at neutral point, and distance from this, from here it is X, the remaining distance will be what? 60 minus X. And now using this equation, K and K cancels from here, we can write this as Q1 Q0 divided by X square equal to Q2 Q0 divided by R minus X whole square. Now applying this over here, what we can get? If here is another charge Q0, so we can get 4 into Q0 divided by X square is equal to again 36 into Q0 divided by 60 minus X whole square. Now cancelizing this, we can get 9. So here it will be 1 upon X square equal to 9 divided by 60 minus X whole square. Now taking square root of all sides, we can get 1 by X is equal to 3 divided by 60 minus X. Now further solving this, we can get 60 minus X is equal to 3X, and X will be equal to what? 3 plus 1 4, and 60 by 4 will be equal to what? 15 centimeter. Now another question is that if these two charges are of opposite signature, let's say this, that these two charges are what? Minus 2 microcoulomb and plus 50 microcoulomb. So where could be the neutral point? It could not lie between the line joining of these two. If I am taking this as point P neutral here and Q0 charge over here, what will happen? It will get attracted by this minus 2 coulomb charge, and it will get repelled by the plus 50 coulomb charge. So here net force on this charge at this point could not be 0. So for this, we will be taking the point on the line joining of these two. Let's say at this point P as neutral point, and let's say distance of this as X. Now distance between these two is what? 80 centimeter. So if it is 80 centimeter, then what will be the distance between BP? It will be equal to what? 80 plus x. Now again, using these two concepts, F1 is equal to F2. Now what will be the direction of F1? Due to this minus 2 microcoulomb and this plus 50 microcoulomb. What will be the direction of this? One will be attracted, let's say this as F1 due to minus 2 microcoulomb, and due to this plus 50 microcoulomb, the charge particle at P will get repelled. So let's say this as F2. Now equating these two, F1 and F2, what we can get? We can get F1 as Q1 Q2 by R square, that will be equal to 2 into Q0 divided by X square, and remaining will be like this, 50 into Q0 divided by distance between them is what? 80 plus X whole square. Now this cancellized over here, we can get 25. Now remaining will be 1 by X square equal to 25 divided by 80 plus X. Now taking square root of these two, what we can get? 1 by X is equal to 5 divided by 80 plus X. Now further solving this, we can get the value of X. So I am writing over here like this, 80 plus X is equal to 5X. Now what will be? 80 equal to 4X and X will be equal to what? 20 centimeter. So here it should be noted carefully that for the two positive charges, neutral point will be in between the line joining, and for two opposite charges, the neutral point will be on the extended line.